All right, let's just jump right in. We're living in a really strange paradox right now, aren't we? We have modern AI that can compose poetry, it can write software, it can even pass the bar exam. And yet, we can't really trust it with anything that's truly high stakes, like a critical medical diagnosis or the specs for a bridge. Why is that? Because for all their incredible power, these models are fundamentally unreliable. And this quote, wow, it just hits the nail on the head, right? It perfectly captures the core problem. We've all experienced this. You ask an AI a question, and it gives you back an answer that is so well written, so confident, you just assume it has to be true. But then you go to check the facts, and you realize it was a complete and total fabrication, a hallucination. So there's actually a name for this invisible wall that we all keep hitting. Engineers call it the stochastic cliff. It's that moment of pure frustration where the AI either just makes something up that sounds plausible, or it gives you that polite but useless canned response. As an AI language model, I cannot fulfill this request. It's just an illusion of safety, not actual real safety. So what is really going on under the hood here? Well, the groundbreaking paper that introduced the Falcon architecture argues that this isn't some simple software bug that we can just patch over. No, it's a deep, fundamental flaw in the architecture itself. Our AIs are literally missing what neuroscientists consider the essential layers for conscious access. Okay, so according to what's called the global neuronal works theory, there are three conditions for this to happen. First, you have C0, the unconscious. Just think of this like driving on the highway and not remembering the last 5 miles. It's fast, automatic, pattern matching. And current AI is amazing at this. But then there's C1, the global broadcast. This is when your brain suddenly spots a deer on the road and every single part of your system locks onto that one single verified fact. Our current LLMs, they just can't do this. They just keep flowing forward statistically. And they completely, utterly fail at C2, which is self-monitoring, the simple ability to know what you don't know. And this is such a critical point. When an AI refuses to do something dangerous, it's not because it's actually consulting some internal safety manual. It's just role-playing. It's seen millions of examples of humans politely saying no to things, and it's just mimicking that pattern. It's like an actor on a medical show who says it's a rare form of vasculitis with total conviction, but they've never seen a patient or run a single blood test. And that right there is why they're so easy to jailbreak. And this is how the Falcon architecture is built to fix those exact failures. You can see right away, this is not a patch, it's a total redesign. It introduces completely new components, like advanced encoders for that unconscious part, a hash-indexed broadcast system to finally solve C1, and something called provenance chains for self-monitoring. It is a system built from the ground up to satisfy all three of those conditions for consciousness. So let's get into the guts of this thing and see how this new architecture actually works. Because this really isn't about just building a slightly better chatbot. No, the Falcon architecture is a complete paradigm shift in how we even think about machine intelligence. And a central metaphor here, it just says it all, doesn't it? Current AI is like a ballistic missile. You do all the math once, you fire it, and you just hope it hits the target. If that target moves, well, you miss. The Falcon, on the other hand, is like a real peregrine falcon. It is in a constant, high-speed feedback loop, always checking against reality, always adjusting its course to stay locked on the truth. So, to build a system that can actually do that can course correct with reality, you have to change the most fundamental piece, the very atoms of information that it uses. You have to move from just statistical fragments to actual verifiable units of thought. You see, today's AI models use tokens, which are really just meaningless little fragments of words, like ing or the. The Falcon architecture introduces something totally new, the tokum. That's T-O-K-U-M. And a tokum isn't a piece of text. It's a cryptographically verified unit of thought that fuses a concept, its context, and its proof all into one package. So what is a tokum? Well, it has 3 core parts. First, there's the CCI, the canonical comprehension identity. Think of this as a forever, permanent, unchangeable mathematical address for a pure concept, like water. Second, you have the CTI, or contextual token instance. This is what grounds that abstract idea in a specific situation. You know, the water in a chemistry textbook is very different from someone screaming water on a flooding summer in. And finally, and maybe most importantly, there's the provenance chain, which is like a cryptographic receipt that proves, without a doubt, exactly where this information came from. And this is where it gets kind of mind-blowing, the CCI. If you take a really precise definition of a concept, like H2O for water, and you run that definition through the exact same cryptographic algorithm that powers Bitcoin, SHA-256, you get a unique hash, a unique address. And here's the magic. Anyone, anywhere in the universe who uses that exact same definition will get the exact same hash. We're not assigning an ID to water. We are literally discovering its permanent address in mathematical space. So here's maybe the best way to think about the difference. Today's AI. It's like it takes the entire internet, throws it all into a giant blender, and serves you a statistical smoothie. You've no idea what the original ingredients were or where they came from. Falcon refuses to blend the fruit. It serves you the strawberry with the farmer's cryptographic tag still on it, telling you exactly who grew it, when it was picked, and who verified it was fresh. This is how it completely solves the problem of source amnesia. Okay, I know what you're thinking. All this cryptographic verification on every single unit of meaning, that sounds unbelievably expensive. Won't this just melt the global power grid? And yeah, that's a fair question. And the answer is maybe the biggest technical surprise in the whole paper. Turns out, no, because the Falcon architecture runs on a completely new data structure called the HCNV Colbert matrix. And the secret to its insane efficiency is sparsity. As you can see here, almost all of it is empty. It is 99.75% sparse. Let's use an analogy. A dense system, like a normal AI, is like trying to speed read every single book in the entire library for every single question you ask. It's just ridiculously wasteful. A sparse system, like Falcon, knows that your question about apple farming has absolutely nothing to do with the schematics for a submarine. So it leaves that entire section of the library powered down, walks silently to the one correct shelf, and pulls out the one verified book it actually needs. And look at the payoff. Just look at these numbers. A complex query on a big, dense transformer model might burn 100,000 watts of power. The exact same query on the sparse Falcon system? About 1 watt. That's not just an improvement, that is a complete thermodynamic paradigm shift. It's orders of magnitude more efficient and a heck of a lot closer to the 20 watts that your own brain runs on. Now, once you have that kind of incredible efficiency, it opens the door to something much bigger, a much deeper philosophical shift. It lets us move away from this idea of artificial intelligence as some kind of hoarded secret asset and towards something the paper calls agapistic influence. And we're not just talking about building smarter machines in a data center anymore. This shift from a closed-off, walled garden artificial intelligence to a flowing, connected, agapistic influence, it's a new definition of intelligence that applies to all living systems, and that includes us. So what is it exactly? Well, the term comes from agape, which is the Greek word for a kind of selfless, evolutionary love. And the definition is so simple but so profound. A system is intelligent only if it reduces stress and increases harmony in the larger system that it is a part of. This quote from the paper it reframes everything. For years, we've been terrified of some AI that hoards all the knowledge in a box and becomes all-powerful. But this new definition says that's not even intelligence. Intelligence isn't a possession. It's not something you accumulate. It's a process. It's what flows through you to help the whole. And that really brings it all back home, doesn't it? It leaves us with this one really challenging question to think about. If true intelligence is measured by how much stress you relieve in the systems you serve, your family, your community, your planet, then how intelligently are we as a species actually behaving right now? Are we really reducing stress, or are we just adding to the noise?